Lesson 3, the shifted form of the parabola. So in our past lessons, we've talked about our basic form of the parabola, and that basic form was y equals x squared. Well, today I'm going to name that, and that guy right there is called the parent function. It's the quadratic's most basic form, and to be honest, it's quite boring, all right, the parent function. Well then, all the different variations that come off of the parent function tend to get a little bit more interesting. So what we're going to do is, today we're going to talk about the turning point, okay? That's going to be our main focus, is the turning point, or the vertex of our parabolas, and how things are going to start to shift and move around. So, in exercise 1, it says, without using your calculator, sketch each of the parabolas shown below on your own set of axes. State the coordinates of the turning point of both. So in both A and B, you did both of these in our previous lesson. So basically, what we focused in on so far is if that number is positive, that A is positive, we know that the parabola opens up, or it smiles, okay? It's concave up. And you hopefully, I know you noticed that how wide or how narrow that parabola was opened changed when we started to change that A. And then in exercise B, negative 3x squared. So that coefficient there, being that it's negative, it frowns or it opens down. Okay, it's concave down. And it was still centered, or I should say the vertex, the turning point, was still at the origin. So now this parent function, which we graphed in our last lesson as well, right? The A is 1 and it's positive, so it does open up. So now let's look at those. I have all three of those typed into my calculator. So we're just going to take and examine those for a minute. All right, so the blue one is the parent function. Then the red one was the second one, and then the one that's in black there, that was the third one that we graphed. So you can see that they all have a vertex or a turning point at the origin, 0, 0. And you can also tell when we start to increase our A value, so when it went from 1 in the parent function to 2 in our second function, my parabola got more narrow. And then when we made it a negative, it started to face down, and it's negative 3, so now it's even more narrow than, say, what this positive 2 was in the second function. Let's go back to our notes, and it says, okay, if we have a parabola in this most basic form, y equals ax squared, then its turning point, or its vertex, is at the origin, 0, 0. So now let's look at what if we start to shift this parabola around. So we're going to start to translate it. So consider the basic quadratic function, right? There's the parent function again. You're going to get tired of me saying that. Okay, but it's super important. And then the more complex quadratic function, g of x. So f of x is already graphed for us. I'm going to label that. You should label that as well. And it says, using your calculator to generate a table, sketch a graph of g. So we're going to graph this one. All right? So go ahead, pause it, graph your parent function, and graph g of x, and then come back. So when I take a look at both the parent function and now this shifted function, hopefully you're noticing it still opens up, but it is shifted. The vertex is no longer at the origin. The vertex is now changed. So when you looked at your table on your calculator, what were you able to come up with for some points to graph that? So when I take a look at, and I'm going to graph g of x, I'm seeing that my turning point is at 2, negative 4. And then I was able to grab some more points off of the table, and hopefully you're starting to really see the symmetry that occurs with the parabolas as well. So right there, that's our g of x. So our initial parent function had a vertex at 0, 0. But now, what's the vertex of g of x? So it says, how do you need to shift these two functions, or shift f of x to get your new function g of x? Hopefully you're seeing, just by looking at the vertex, that we shifted 2 to the right and 4 down. We moved 2 right and 4 down. So now, what's the turning point of g of x? It's 2, negative 4. And it says, where do you, and then in quotes, see the turning point in the function's equation? So when I'll rewrite it, so it's right in front of us. Where do you see that turning point in the equation? Hopefully you notice something about that, 2, and then something about that negative 4. Okay. So let's go ahead and flip the page. And it says, let's keep looking at this pattern, but more simply. Let's see again what happens. So our parent function is already graphed for us. Now consider the quadratic function, this and this. So we've got 2 more of them to look at. So go ahead, pause it, graph the parent function, and graph those 2 new functions, and graph them on your paper, and then start the video again. So on your calculator, you should have those 3 functions, and now you should see what has happened to the vertex now when we've changed the equation just a little bit. What you have on your paper, okay, should look like this. I did change colors, and, oops, I forgot to label that third one. Okay, you should have labels. You should see that vertex shift. Your parabolas should be nice and symmetric. The ends of your parabola should have arrows on them. Now the question did not restrict our domain at all, so we need to make sure that we show that those parabolas do continue on to positive infinity. And also the other piece that I was looking at was, the other thought in my head was, when you're going to graph this, and I mentioned the symmetry, to get those nice points, make sure you're looking at your table. Okay, find that vertex on your table to then start to be able to pick points to graph. So if we hit our Control T and examine the table, okay, there's the vertex for my parent function, and then I'm going to pick 3 points to one side of the vertex, to the left of the vertex, and then 3 points to the right of the vertex. And then I do the same thing with the second one. Right there, 0, 2, that's my vertex for the second function, and now you can start to see the symmetry on either side, okay, of that vertex. And then the same thing for the third one that we graphed. Find the vertex, and then be able to pick 3 points to the left of the vertex and 3 points to the right of the vertex, and you're going to get that nice looking symmetrical parabola. All right. So what was the effect of adding a constant to the overall function? So when we added 2, what happened to it? Okay, that parabola shifted up 2. Okay. Well, what about when we added a negative 4? Because that's essentially what was going on. Okay, that shifted down 4. So it says state the coordinates of the turning points of each of the parabolas that you drew. So this first one is 0, 2, and this one is 0, negative 4. Okay. So now you don't have a picture in front of you, take it and generalize it. what's going to happen with this. And hopefully you're realizing that your vertex will be that. Okay? So now let's see about the number added or subtracted from the input variable x before it's even squared. So I'm going to let you guys do these on your own. Do a little bit of that exploring on your own and see what kind of patterns you can come up with, and then we're going to talk about them in class tomorrow.